At this point, we have sufficient enough information to do most common trig things that will come up. And what we're going to look at now is ways that we can use some of the nice angles that we know that apply on the unit circle, and then our identities that we have to get exact values. Here are a list of what are called half-angle identities. So consider perhaps if we wanted to find the sine of, say, pi over 8, we know that pi over 4 is a nice angle on the unit circle. And so half of that would be pi over 8, and these identities will come in handy there. To begin with, we're going to prove just one of these. Let's prove that the tangent of x over 2 is equal to 1 minus the cosine of x over sine of x. To do this, let's first look at the tangent squared of x over 2. So if I take the tangent squared of x over 2 using our previous identities, this becomes 1 minus the cosine of 2 times x over 2 over 1 plus the cosine of 2 times x over 2. Notice that that reduces very nicely. If we take the tangent squared of x over 2, that's going to become 1 minus the cosine of x over 1 plus the cosine of x. And then we can take the square root of both sides, which leaves us with the tangent of x over 2 is equal to plus or minus the square root of 1 minus the cosine of x over 1 plus the cosine of x. We can then multiply by the conjugate on the top and the bottom. And so this we multiply by 1 minus the cosine of x over 1 minus the cosine of x. And so we get the tangent of x over 2 is equal to plus or minus the square root of 1 minus the cosine of x squared over 1 minus cosine squared of x. Remember that this is equivalent to sine squared of x. So we have the tangent of x over 2 is equal to plus or minus the square root of 1 minus the cosine of x squared over sine squared of x. And then taking the square root, we get that the tangent of x over 2 is equal to plus or minus the absolute value of 1 minus the cosine of x over the absolute value of the sine of x. Remember that absolute value is important because we can't have a negative under a radical. However, we can also recognize here that this top part is always going to be positive since cosine is bounded by 1. And we can also discard the absolute value on the bottom since the tangent of x over 2 and sine have the same sign and the tangent was positive. So we end up with our proof that the tangent of x over 2 is equal to that identity of 1 minus the cosine of x over the sine of x. Let's do an example of using that half angle identity. If we want to determine the exact angles of the sine of pi over 8, cosine of pi over 8, and tangent of pi over 8, notice that the cosine of pi over 4 on our unit circle is equivalent to the sine of pi over 4. And if you check your unit circle, that's going to be equivalent to the square root of 2 over 2. But notice that pi over 4 divided by 2 is equal to pi over 8. We can therefore apply our half angle identities, and we get that the sine of pi over 8 is equal to the square root of 1 minus the cosine of pi over 4 over 2, which is equal to the square root of 1 minus the square root of 2 over 2 over 2. And once we find our common denominators and reduce, we get that this is equal to the square root of 2 minus the square root of 2 over 4. We can take the square root of 4, which gives us 1/2 times the square root of 2 minus the square root of 2. Likewise, for the cosine of pi over 8, we get the square root of 1 plus the cosine of pi over 4 all over 2. So 1 plus the square root of 2 over 2, again reducing 2 plus the square root of 2 over 4, and we can take the square root of that 4, which gives us 1/2 times the square root of 2 plus square root of 2. And last but not least, the tangent of pi over 8 is equal to 1 minus the cosine of pi over 4 over the sine of pi over 4. So we get 1 minus the square root of 2 over 2 over the square root of 2 over 2. When we deal with that complex fraction, we get 2 minus the square root of 2 over 2. And if we rationalize the denominator by multiplying by the square root of 2 top and bottom, we get 2 square roots of 2 minus 2 over 2. And then the 2's all divide out, leaving us with the square root of 2 minus 1. As the last example of these half-angle identities, we can determine the cosine of 105 as an example. Notice that 105 is 210 over 2. And from our unit circle, we can find that the cosine of 105 is equal to 1 plus the cosine of 210 over 2, which equals the square root of 1 minus the square root of 3 over 2 over 2, or 1/2 square root of 2 minus the square root of 3. But notice it lies in the second quadrant, and so that's going to give us a negative out front of all of these.